Good morning everyone. Friends, today we are going to discuss about the most important phenomenon in the halogen derivative, and that is nothing but the SN1 reaction with the mechanism. So let's begin. Before we are going to discuss about this mechanism, we must know that some basic key points in the reaction. We must know that what is the substitution reaction. What is the substitution reaction? Substitution reaction. Friends, how will you define the substitution reaction? The reaction in which atoms, molecules or ions from the reactant replaced by the another atoms, molecules or ion is called as the substitution reaction. In other words, we can also define such kinds of reaction. The reaction in which the atoms or group of atoms is replaced by the another atoms or group of atoms is also called as the substitution reaction. Next, we must know that what is the nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic substitution reaction is nothing but the simply substitution of nucleophile. Then what is meant by nucleophile? Nucleophile is nothing but the electron rich species which is attack on the electron deficient center. It's called as the nucleophile. Simply, nucleo is the nucleus and phile, that is the filling, loving. So simply, nucleus loving, it is the nucleophile. That is the substitution of nucleophile. It is represented by the general chemical equation. When alkyl halide react with the nucleophile, it gives the formation of corresponding product with nucleophile with the removal of weak nucleophile. That is the halogen atom. So this is the nucleophilic substitution reaction. How will you define this nucleophilic substitution reaction? The reaction in which the atoms or group of atoms is replaced by the incoming nucleophile, or simply we can say that the reaction in which the weaker nucleophile is replaced by the strong nucleophile. So this is about the nucleophilic substitution reaction. Now further we have to discuss about the SN1 reaction. So let's start. Friends, we know very well the alkyl halide is a much reactive and it undergoes the SN1 reaction. So this is due to the large electronegativity difference between the carbon and halogen atom, which provides the great polarity to carbon to halogen. This carbon possesses partial positive charge while halogen atom possesses partial negative charge. And in this way it undergoes the SN1 reaction. The one question is that the tertiary alkyl halide undergo the SN1 reaction. So reason is that there is a positive I effect shown by the number of alkyl group attached to the tertiary carbon atom, and negative I effect shown by the halide ion or halogen atom attached to the tertiary carbon atom, due to which it undergo or it shows the SN1 reaction. So let's start SN1 reaction. S and 1. The 1 is stand for unimolecular, S is stand for substitution, and N is stand for nucleophilic. That is, in this way we call it the SN1 reaction. That is the unimolecular nucleophilic substitution reaction. How will you define this reaction? The reaction in which the rate of reaction depends upon the concentration of only one molecule. The molecule may be the reactant or substrate. This is the SN1 reaction. The simple example of the SN1 reaction is the alkaline hydrolysis of tertiary butyl bromide. It gives the formation of tertiary butyl alcohol. So let's see. Tertiary butyl bromide on alkaline hydrolysis with aqueous alkali like KOH or NOH, it gives the formation of tertiary butyl alcohol with the removal of potassium salt, that is KBr, potassium bromide. This is the best example of SN1 reaction. काय होत आहे या रिएक्शन मध्ये टर्शियरी ब्युटिल ब्रोमाइड मध्ये जो ब्रोमीन ॲटम अटॅच आहे टर्शियरी कार्बनला तो त्या ठिकाणी वीक न्यूक्लिओफाइल आहे, ज्याला रिएजंट मधला हायड्रॉक्सिल ग्रुप आहे जो स्ट्रॉंग न्यूक्लिओफाइल आहे तो त्याला सहज रिप्लेस करतो आणि आपल्याला एक डिझायर्ड प्रोडक्ट देतो ज्याचं नाव आहे टर्शियरी ब्युटिल अल्कोहोल. आणि यानंतर आपल्याला पाहायचं आयोनिक फॉर्मेशन. आयोनिक फॉर्मेशन इज नथिंग बट द सिम्पली डिसोसिएशन ऑफ रिएजंट. इट गिव्स द टू फ्रॅगमेंट पॉझिटिव्ह अँड निगेटिव्ह आयन, and negative ion does take a part in the reaction to proceed and give the formation of alcohol. Ionic formation. With KOH on dissociation gives K positive ion and OH negative ion. This hydroxyl group take a part in the reaction and gives the formation of alcohol. Tertiary butyl bromide plus hydroxyl ion, it gives the formation of tertiary butyl alcohol and halogen ion will be removed. So this is the ionic formation of the reaction. After this we have to discuss the next part, that is the kinetic expression. B, that is the kinetic expression. Friends, we know very well this SN1 reaction follows the first order kinetics. It means that the rate of the reaction depends upon the concentration of only one molecule, that is the reactant, and here reactant is a tertiary butyl bromide. Hence the rate will be depends upon the tertiary butyl bromide. So we can write like this. So R is directly proportional to tertiary butyl bromide, or in other we can write R is equal to K tertiary butyl bromide. Friends, here R is equal to the rate of reaction and K is nothing but the specific rate constant. So here we can say that the rate is depends upon the reactant, that is the tertiary butyl bromide, and not on the hydroxyl ion. So thus it follows the first order kinetics. So after this we have to discuss the mechanism of the reaction, mechanism of the SN1 reaction. Friends, we know that the SN1 reaction is a two-step reaction. This mechanism involves the two steps. First one is the formation of carbocation, that is nothing but the breaking of CBr bond, and second step is the formation of product, that is nothing but the formation of COH bond. So let's see the first step, that is the formation of carbocation. Step first, formation of carbocation, that is the carbonium ion, that is the formation of positively charged carbon atom. So friends, what will be happen during this step? We know that as the electronegativity of bromine is more, the CBr bond become a polar. This is due to the positive I effect shown by the alkyl group and negative I shown by the halogen atom. So what is the positive inductive effect? Inductive effect is nothing but the permanent polarization of the single covalent bond due to the electronegativity difference between the atom joined by the bond is called as the inductive effect. It is also called as the transmission effect. Then what is the positive inductive effect? The positive inductive effect is shown by the alkyl group attached to the tertiary carbon atom. It means that the atoms or molecules which repels or pushes the electron shared paired toward or away from itself. This is called as the positive inductive effect. As atoms or molecules which withdraw or attract the shared electron paired toward itself is called as the negative I effect or negative inductive effect. So what will be happen? The CBr bond in aqueous alkaline solution slowly ionize, and this break heterolytically gives the formation of carbocation, which is stabilized by the bromine ion and resonance. So let's discuss this step. So what will be happen? Tertiary butyl bromide This is the first step. We can see here the tertiary butyl bromide which form the maximum energy content state, that is nothing but the transition state. What is the transition state? Transition state is nothing but the maximum energy content state shown by the reactant as product. And first thing, always keep in mind that the every reactant before convert into the product pass through the state. This is the transition state. And after this, the bromine atom will be removed and it form the carbocation, and this carbocation is stabilized by the resonance and bromine ion. The central carbon atom of the carbocation undergoes sp2 hybridization and hence it has a planar structure, and the CH3 bond angle is 120 degree. And friends, first thing, always keep in mind that the first step is a slow step, and hence this step is called as the RDS step, that is the rate determining step, because the rate of this reaction we can easily determine, hence it is the rate determining step. After this, we have to discuss about the second step, that is nothing but the formation of product. What will be happen during the second step? The carbocation is formed in the first step. What happened in this case? The incoming nucleophile, that is the hydroxyl ion, will directly attack on this positive charged carbon atom of carbocation from any site and gives the formation of desired product, that is the tertiary butyl alcohol, with the 50% retention and 50% inversion. It is also called as the racemization of configuration. So let's see. So you can see this the step, second step, that is the formation of product. So what will be happen in this step? The simultaneous breaking of that is the hydroxyl group attack on this positive charged carbon atom. This incoming nucleophile, that is the hydroxyl ion, will attack on this positive charged carbon atom and it form the maximum energy content state. That is the transition state in the second step. So after this hydroxyl group attack on this carbon atom from any side, and you can see there is the formation of two same products. That is the same product having the same physical properties, same chemical properties. Only difference is that it has the different configuration, that is the different formation, that is called as the 50% retention and 50% inversion, that is the racemization of configuration. What is the racemization? Racemization is nothing but the conversion of dextro and levo form into the receiving mixture is called as the racemization. Or in other words, what is the receiving mixture? The equimolar mixture of dextro and leo form is called as the racemic mixture. In such a way that we obtain the desired product, that is the tertiary butyl alcohol, and this is about the second step. So this is about the mechanism of SN1 reaction. And friend, first thing, always keep in mind that the second step is not the RDS, rate determining step. This is a fast step, and hence we cannot determine the rate of this step, and hence it is not said to be rate determining step. So this is the second step of mechanism. After this, we have to see the next, that is the EPD. Point C, EPD. What is EPD? That is the energy profile diagram. How will you define the energy profile diagram? The curve or a graph which is obtained by plotting the potential energy against the progress of reaction, or the reaction coordinate is called as the EPD, that is the energy profile diagram. So let's plotting the graph. This is a y-axis, x-axis. There are the two peaks, potential energy against the progress of reaction, or we can say the reaction coordinate. The higher peak is nothing but the TS1, that is the transition state in the first step. What was the transition state? Tertiary butyl bromide. Here carbon gets partial positive charge while bromine gets partial negative charge. This is the first transition state. Then lower peak, that is the TS2. Transition state formed in the second step. This is the tertiary butyl alcohol. Here carbon gets partial positive charge, hydroxyl gets partial negative.